Good morning. I am Dr.S.SURYA, Assistant Professor, Department of Chemistry, A.D.M. College for Women, Nagapattinam. Today we are going to learn about chemistry in everyday life in first semester chemistry. We are going to first one, water chemistry. What is meant by water chemistry? Water is a chemical compound consisting of 2 hydrogen atoms and 1 oxygen atom. The name water typically refers to the liquid state of the compound. The solid phase is known as the ice and the gas phase is called steam. Then introduction of the water chemistry. The nature most abundant supplementary, that is, water is essential for the survival of all the living beings on earth, that is, man, animals and plants. Water is not only essential for the survival of life, but it is also used for the operation in a large number of industries as coolant, solvent, for steam generation, for air consumption, firefighting, etc. Water is also used for all domestic purposes like bathing, drinking, washing, sanitary and irrigation, etc. Then importance of water. Water is the main compound found in living organism. Approximately 62% of the human body is used in water per day. It is liquid form. Water is transparent and nearly colorless. Large volume of liquid water and ice are blue. The reason for the blue color is the weak absorption of light at the red end of the visible spectrum. Pure water is flavorless and odorless. About 71% of the earth's surface is covered by water. Breaking it down, 96.5% of water in the earth's crust is found in ocean, 1.7% in ice caps in glaciers, 1.7% in groundwater, a small fraction in river and lakes, and 0.001% in clouds, water vapor and precipitation. Only about 2.5% of the earth water is fresh water. Nearly all of the earth water, 98.8% is only in ice in groundwater. Water is the third most abundant molecule in the universe after hydrogen gas and carbon monoxide. The chemical bonds between hydrogen and oxygen atoms in a water molecule are polar covalent bond. Water rarely forms hydrogen bond with other water molecule. One water molecule may participate in a maximum of 4 hydrogen bond with the other species. Water has an extraordinary high specific heat capacity, that means 4.1814 joule per kilo at 25 degree, and also a high heat of vaporization, that means 40.65 kilojoule per mole or 2257 kilojoule per kilogram at the normal boiling point. Both of these properties area are a result of hydrogen bonding between neighboring water molecules. Water is nearly transparent to visible light and the region of ultraviolet and infrared spectrum near the visible range. The molecule absorb infrared, ultraviolet and micro radiation. Water is an excellent solvent because of its polarity and highly dielectric constant. Polar and ionic substances dissolve well in water, including acid, alcohols and many salts. Water displays capillary action because of its strong adhesive forces. Then types of source of water pollutant. Water bodies can be polluted by a wide variety of substances, including pathogenic microorganisms, perishable organic waste, fertilizer and plant nutrients, toxic chemicals, sedimentation and heat, petroleum and radioactive substances. Several types of water pollutant are considered below for the discussion of the handling of sewage and other form of waste produced by human activities. The water pollutant come from either point sources or disposed sources. The point source is the pipe or channel, such as those used for discharge from an industrial facility or a city sewage system. A disposed or non-point source is a very broad unconfined area from which a variety of pollutant enter the water body, such as the runoff from an agricultural area. Point source of water pollution are easier to control than dispersed source because the contaminated water has been collected and conveyed to the one single point where it can be treated. Pollution from dispersed sources is difficult to control, and despite much progress in the building of modern sewage treatment plants, dispersed sources continue to cause a large fraction of water pollution problems. Domestic sewage. The domestic sewage is the primary source of pathogens, disease-causing microorganisms and perishable organic substance because pathogens are exhausted in phases All sewage from cities and towns is likely to contain pathogens of some type, potentially presenting a direct threat to public health. Special organic matter present a different sort of threat to water quality. As organics are decomposed naturally in the sewage by bacteria and other microorganisms, the dissolved oxygen content of the water is diluted. This endanger the quality of lakes and streams where high level of oxygen are required for fish and other aquatic organisms to survive. Sewage treatment process reduce the level of pathogens and organics in wastewater, but they do not eliminate them completely. The improper disposal of solid waste is a major source of water pollution. Is a solid waste. The solid waste include garbage, rubbish, electronic waste, trash and construction, demolition waste, all of which are generated by individual, residential, commercial, institutional and industrial activity. The problem is especially acute in developing countries that may lack of infrastructure to properly dispose of solid waste or that may have inadequate resource of irrigation to limit improper disposal. In some places, solid waste is intentionally dumped into bodies of water. The land pollution can also become water pollution if the trash or other debris is carried by animals, wind or rainfall to bodies of water. Significant amount of solid waste pollution in inland bodies of water can also eventually make their way to the ocean. Solid waste pollution is unsightly and damaging to the health of aquatic ecosystem and can harm wildlife directly. Industrial waste. The industrial waste has very variable quality and volume depending on the type of industry producing it. It may be highly biodegradable or not at all, and may or may not contain compounds reculinate and treatment. These include organic synthetic substance or heavy metals whose content in developing country wastewater may be considerably different from that of developed ones. The main concern with industrial wastewater is the increasing amount of synthetic compound contained in and discharged to the environment. The agricultural waste, the plant residue from agriculture, the waste streams originate from arable land and horticulture. Agricultural waste are all part of crops that are not used for human or animal food. Crop residue consists mainly of stems, branches and leaves. It is estimated that on average 80% of the plant of such crops consist of agricultural waste. Removal of heavy metal ions from wastewater is most important in the current situation. The presence of heavy metals in wastewater has been increasing with the growth of industry and human activity, that is plating, electroplating industry, batteries, pesticides, mining industry, rain industry, metal rinse process, tanning industry, fluidicide bed bioreactor, textile industry and such as paper manufacturing and electrolysis application. That heavy metal contaminated wastewater find its way into the environment, threatening human health and the ecosystem. The heavy metals are non-biodegradable and could be carcinogenic. Thus, the presence of these metals in water by improper amount could result in critical health issues to the living organisms. The most popular heavy metals are lead, zinc, mercury, nickel, cadmium, copper, chromium, arsenic. Although these heavy metals can be detected in traces, however, there are still hazardous. The summarize of some heavy metals focusing on their major sources, health effects and the permitted quantity in drinking water. Mentioned metals and others such as silver, iron, manganese, molybdenum, boron, calcium, antimony, cobalt, etc. are commonly available in wastewater and need to be removed. Recent studies have focused on a particular method for heavy metal ions removal, such as electrocoagulation, adsorption using synthetic and natural adsorbents, magnetic field implementation, advanced oxidation process, membrane, etc. These studies stood on the advantages and disadvantages of a specific method for wastewater treatment, including heavy metal removal. A complete picture of heavy metals removal method from wastewater resource has not been drawn yet. Therefore, the present review comprehensively and critically discuss the available technology to expel the heavy metal ions from wastewater efficiently. Moreover, it is essential to choose the most applicable method based on the removal efficiency, chemicals added or absorbent, initial concentration, optimal treated pH value and other operating conditions. The method discussed in this review are classified into adsorption, membrane, chemical, electric and photocatalytic based treatment. An assessment for each method is conducted. Additional details about the operating condition, removal efficiency and the important remarks of each method are listed in the reported studies in the literature survey in the accompanying supplementary information file. The literature is selected based on the availability of the operating and performance parameter for each method. The adsorption based separation is an important method, is a peculiar method, is an important and interesting method, is adsorption based separation. The adsorption mechanism is defined by the physicochemical parameters of adsorbent and heavy metal and operating condition, that is the temperature, adsorbent amount, pH value, adsorption time and initial concentration of metal is very important to such study. Generally, heavy metal ions can be absorbed onto the adsorbent surface. The method was reported to have low operation cost, high removal capacity, easily implementation and simple treatment by regenerating the absorbed heavy metal ion. Different types were developed for wastewater remediation as discussed in the following sections. Heavy metal ions adsorption process. The metal ions of wastewater adhere to the surface of nanoporous adsorbent which has a high surface area due to the porosity. The porosity is an important one, the adsorption capacity. The adsorption process could be selective for one or more metal than others. The regeneration process could be achieved using a dissolving agent. The various modification techniques, that is nitrogenation, oxidation and sulfuration, are used to functionalize the carbon with different functional group. Functionation enhance adsorption capacity and stability. Carbon-based adsorbent is a nanopores adsorbent, especially activated carbon nanotubes and graphene and extensively used in the application of heavy metal removal owing to their terminal surface area, that means 500 to 1500 meters squared per gram as whole power hectare. The carbon surface charges can be enhanced by surface functional groups such as carboxyl, phenyl and lactone groups to remove the heavy metal uptake. Among various modification methods, nitrogenation, oxidation and sulfuration are not the most commonly employed techniques to enhance the specific surface area, pore structure, adsorption capacity and thermal stability and mechanical strength. However, they depend mainly on the adsorbent materials which sometimes are very expensive. Subsequently, adsorbent cost should be considered in choosing the most suitable adsorbents. The surface modification often reduces its surface area and it in turn increases the content of surface functional group. Consequently, more metal ions can be absorbed. Summarize the removal capacity and characteristic of carbon-based adsorbent and composite adsorbents. The adsorption uptake increases by increasing adsorbent surface area, adsorbent dose and initial concentration, metal ions and contact time. Although the multi-wall carbon nanotubes have received particular interest for heavy metal removal. They are highly hydrophobic and suffer from rapid aggregation in aqueous solution due to large van der Waals force, decreasing the adsorption potential. There is a carbon-based adsorbent. Moreover, the current surface modification technique demand high heat or pressure, strong acid or base, or intensive oxidation or reduction reaction. This complex preparation process makes the carbon-based adsorbent expensive, prolonging their widespread use in industrial application. Thus, researchers should propose innovative, low-cost and environmentally friendly surface modification technique has been used. Cytogen-based adsorbent. The cytogen is a natural adsorbed polymer. It has an affinity toward pollutant in wastewater because it is amino and hydroxyl group. Despite its unique features, it suffers from low mechanical strength and poor stability, making a regeneration inefficient. Also, it is challenging to use carbon sign in power or flake from because if a low porosity, low surface area, resistance to mass transfer and high crystallinity. Consequently, structure and chemical modification have been proposed to overcome these drawbacks. Cross-linking Chemical modification impact strength to COs by bridging between polymer chain and the functional group. Grafting is another chemical modification method that involves the covalent bonding of functional group like amine or hydroxyl group and the backbone of CS. Cytosion based method leading to a remarkable increasing in the adsorption capacity. Combining CS with the other adsorbent materials has also been proposed to enhance the CS adsorption capacity. Mechanical strength and thermal stability is enhanced the capacity of CS adsorption capacity. The ion imprinting technique was followed to prepare adsorbent with high selectivity for target of metal ions. The top 5 heavy metal ions found in tap water. Heavy metals are natural formation in the earth crust named for their high density. These metals include some of the most common ones on earth such as tin, gold, copper and silver, which are widely used in agriculture and manufacturing. Many of these metals are essential to human body function but in large doses. It can cause serious toxicity, especially in children and developing fetus. These are several heavy metals on the World Health Organization, that means WHO, list of chemicals of major public health concern, including lead, cadmium, mercury and arsenic, all of this which can be found in tap water. Here at A.D.M.COLLEGE, we are dedicated to educating people about the potential risk of drinking tap water and providing helpful tips to prevent toxicity. Then manganese is one of the heavy metal ions in the water. Manganese is a common metal used in different type of aluminum alloys as well as additive in unleaded gasoline, pumping materials, battery cells, fireworks and a component of tobacco smoke. Manganese is an essential nutrient required by our body in small amount. Only trace amount we have to need. However, exposure to high concentration can cause nervous system toxicity. The heavy metal is found in the surface and water, which is how it can be make its way into your water supply. We suggested having your water tested by a professional to ensure there are no toxic level of manganese in our water. The cadmium is a common heavy metal used in metal plating, machinery and batteries. Cadmium poisoning can occur when consuming plants and animals that were exposed to contaminated water or soil. However, the World Health Organization explains that calcium usually makes its way into our water through impurity in the zinc of galvanized pipes and soldering fitting, water heater, water cooler and taps. Short-term exposure to this heavy metal can cause nausea and vomiting. But more serious overexposure can lead to cancer as well as kidney, liver and musculoskeletal damage. Then arsenic is a common very heavy metal in the earth crust, sometimes resulting from volcanic activity or other natural process. However, human activities such as pesticide production and mining have led to increased concentration of arsenic in groundwater. Arsenic is one of the most toxic heavy metal that can make its way into our water through natural erosion from rocks and soil, agriculture runoff from orchards or waste stream from metal and electronic industry. In small doses of organic arsenic exposure can cause skin discoloration, stomach pain, nausea and diarrhea. However, chronic arsenic poisoning can cause neurological problem, cardiovascular disease, immune system disorder, cancer of the bladder, lungs, skin, kidney, liver or prostate and even endocrine issues such as diabetes. Then copper. So copper is the most common heavy metal in the appear in tap water. This is because copper can leach into the tap water, it pipes and other plumbing features begin to corrode. It can also get into your water supply if the groundwater has not been sufficiently treated. Copper is another element that is essential to your health. But too much of it can cause vomiting. It's also like arsenic molybdenum, vomiting, diarrhea, stomach cramp and even kidney and liver disease. Lead is a fairly soft, highly malleable, naturally occurring metal that is considered harmful at any dose. The most common way it get into our drinking water is through a corrosion of pipe or plumbing fixtures. Older homes are often equipped with copper plumbing systems that are prone to corrosion. So this is most likely to occur in other old homes. Now, New rule created for developer and homeowners in 1966 restricted the threat of the lead in drinking water, even though it was still using plumbing materials until the 1980s. Lead is also get into our water source when natural deposit into it or when industrial activity leaks it directly into your water. Even small amount of lead in your water can be dangerous as it accumulates in your body over time, causing damage your brain, liver, kidney, heart or bones. Exposure to lead can also cause autoimmunity, causing your immune system to attack its own cells, leading to nerve system dysfunction of kidney disease. Children are especially vulnerable to lead poisoning. Thank you.